Hello dear students, good morning. Welcome back to the chemistry class. So in today's session, we'll discuss a very small concept and the easiest topic that already we have studied in class 11. Just we can recap. That is isomerism in alcohols. Topic isomerism in alcohol. So here, what is meant by this term isomerism? Isomerism. Yes. What is the definition of this term? Isomerism. Yes. Two or more compounds which having same molecular formula but different properties are called isomers, and the phenomenon is called as isomerism. And the concept of isomerism, the isomerism or isomers are classified into different types: structural isomerism and stereoisomerism. In structural, we have studied total 5 types: chain isomerism, positional isomerism, functional isomerism, metamerism, and tautomerism. Whereas in stereoisomerism, again in stereoisomerism, different types we have studied: geometrical isomerism and optical isomerism. In geometrical, cis and trans, RS configuration, EZ nomenclature, etc. And optical isomerism is again separate, and also we have studied in haloalkanes and haloalkanes regarding optical isomerism. So here alcohols are also exhibit some types of isomerism. So those concepts we are going to deal in this topic. So here alcohol in isomerism in alcohols. These alcohols are also exhibit some types of isomerism. That is number one. First one is chain isomerism. What is meant by this? This chain isomerism. The compounds which having, look at the examples, the compounds which having same molecular formula CH3, 4 carbon atoms, 4 carbon atoms, CH3, CH2, 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 and one OH group. What is the molecular formula? C4. So here the formula is C4. How many hydrogens are there? 9 hydrogens. C4H9 and one OH group. C4H9OH. Here also the formula is same. C4H9 and one OH group. C4H9OH. But so the number of carbon atom in the parent chain is different. CH3, CH, CH2, CH3, and this is an OH group. Compounds having same molecular formula but differ in their structural formula. In which structural formula, what type of difference it is? So differ in the parent chain, number of carbon atom in the parent chain. So look at this. In the first case, 4 carbon atoms are present in this compound, whereas only 3 carbon atoms are present in the parent chain. Therefore, it is said to be a chain isomers. These two are chain isomers of each other, and the phenomenon of existence of this is called as chain isomerism. This is very simple. So, different chain, carbon chain. If we are considering 5 carbon atoms, we can write this 3 structure as it is. So, if 5 carbon atoms are there, CH3, CH2, 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 and CH2OH. N-pentanol. N pentanol, that is 5 carbon atoms. 1, 2, 3, 4, 5. N pentanol. So in this case, in case of N pentanol, we can write in case of N pentanol, that is number one, first one. So here N pentanol, one's first structure, second one CH3, CH3, CH2, CH3, CH2, CH2, CH2. So here total 5 carbon atoms, here only 4 carbon atoms, OH group. So there is a difference in the carbon chain. One CH3, CH2, CH2, CH3, CH3, this is only hydrogen, CH3, CH3, CH2, OH. Look at this, these are the chain isomers of each other, because the compounds which having the same molecular formula, same functional group, but differ in the parent chain, that is carbon chain. 5 carbon atoms, 4 carbon atoms, and 3 carbon atoms in the parent chain. So therefore we can say the alcohols can exhibit chain isomerism. Chain isomerism, because there is a difference in the carbon chain. Now the next one is, the next one in this case, the next one is, next one, that is chain isomerism, positional isomerism. Positional isomerism. Positional isomerism. So in this positional isomerism, as the name itself indicate, the functional group differ in the position of the carbon. Okay, isomerism. Two or more compounds which having same molecular formula, same functional group, but they are differ in the position of a functional group, are called as positional isomerism. Positional isomers, and the phenomenon is known as positional isomerism. Look at this. The functional group OH is present on the first carbon atom in structure number 1, whereas the same OH group is present on the second carbon atom. So its name is 1-propanol. So here it is prop, single bond N, 1 all. At first position OH group is present, whereas in the second structure it is propane, 2 all. So the compounds which having same molecular formula, C3H7OH, C3H7 and OH. So here also it is same, C3H7OH, C3H7OH. The molecular formula is same, functional group is also same, but these two are differ in the position of a functional group. Therefore these are said to be positional isomers, and the phenomenon is known as positional isomerism. The first one is chain isomerism, second one is positional isomerism. The next one is chain isomerism, positional isomerism. Third one is functional isomerism. Functional isomerism. Functional. So that means these are differ in their functional group itself, right? Functional isomerism. So for example, if you consider C2 C2H5OH. What are the possible structure for this? C2H5OH. Or we can write, instead of writing this, C2H6O. This is the molecular formula. C2H6O. C2H6O. Two or more compounds which having same molecular formula but differ in their functional group itself, that is called functional isomer. So here we can write this as CH3 CH2OH. So here the functional group is OH, where it's also it can be written as CH3 or CH3. So molecular formula is same, but differ in their functional group. Here it is an alcohol. This is an alcohol, whereas this one is ether. Alcohol and ether. The first one, this is alcohol functional group, and this is ether functional group. So two or more compounds which having the same molecular formula, even they having the same molecular formula, but they are differ in their functional group itself. Therefore, it is called as functional isomerism. Functional isomers, and the phenomena is known as functional isomerism. Functional isomerism. Is it clear? Okay, right. And one more type of isomerism is exhibited by this, that is optical isomerism. One more type is optical isomerism. Optical isomerism. Regarding this optical activity and all, we have explained in the last topic, that is haloalkanes and haloarenes. So here, in order to exhibit an optical isomerism, the compound must and should contain a chiral carbon atom. That means the carbon attached to four different groups. Let us consider this first one. That is a carbon atom which having four different groups. Four different groups. Optical activity is nothing but what? Optical isomers are the mirror images of non-superimposable mirror images of each other. If the carbon containing four different groups, let's say H hydrogen, H, OH, CH3, C2H5Y, C2H5, C2H5. So total three different groups are attached to this carbon atom. Therefore, it is said to be a chiral carbon atom. It can optically active compound, we can say. So here, exactly the mirror images of this is OH group, its mirror images, CH3, so this is CH3 group is here, and C2H5, C2H5, and this is the hydrogen. These two compounds are said to be optical isomers because the compounds having same molecular formula, they are non-superimposable mirror images. So here the phenomenon of existence is known as isomerism, right? So here this also a chiral carbon atom, an asymmetric carbon atom. Asymmetric is nothing but what? Asymmetric carbon, chiral carbon atom is nothing but the carbon which containing four different groups are said to be chiral carbon atom, and this is the necessary condition to obey an optical activity. So optically active compound must contain this chiral carbon atom. So this carbon atom has the tendency to rotate the plane polarized light either towards right or towards left. Therefore, it is said to be an optically active compound. So here, the functional group, if alcohols, the chiral carbon atom which containing an alcohol which obeys or which act as an optically active compound because it have a tendency to rotate the plane polarized light either towards right or towards left. So therefore we can say it exhibit optical isomerism also. So these are the four types of isomerism can be exhibited by alcohols. Is it clear? Or so first one is which isomerism? First one is first one is first one, that is chain isomerism. The compounds which having same molecular formula, same functional group, but differ in the carbon chain, parent chain. That is called chain isomers, and the phenomena is known as chain isomerism. That is first one. Whereas the second one is positional isomerism. Compound having same molecular formula, same functional group, but differ in the position of a functional group is said to be positional isomer, and the phenomena is positional isomerism. Next one is functional isomerism, that is compound having same molecular formula but differ in the functional group itself is called as functional isomers, and the phenomenon is said to be functional isomerism. And the last one is optical isomerism. Optical isomerism. That means two compounds which having the same molecular formula but differ in their rotation of plane polarized light, because the one compound which rotate the plane polarized light towards the right side, then the other compound which rotate the plane polarized light towards the left side. So therefore these two are optical isomerism. So this is the concept of isomerism in alcohol. Okay. The next concept, that is IUPAC nomenclature, will continue in the next session. Okay. Thank you.